All right, moving on to our final speaker of the day before we get to questions. I'd like to introduce Mr. Greg Young. For more than 3 decades, Greg Young has guided clients through the dynamic integration of legal, economic, political, and technical elements that course through all water resource planning and management challenges. His foundational expertise from extensive water work throughout California and the Southwest on projects ranging from innovative water transactions to demand and supply characterization and forecasting to drafting legally defensible documents enables creative and comprehensive client solutions. Please welcome Greg Young.
Thank you. So what do we just advance?
Just hit the arrows.
Okay, perfect. Thank you. Is everybody awake? Do we need to stand up for once? Because I tried to eat a little bit of lunch because otherwise I was going to have food coma. So I'm guessing a lot of people, a little bit of food coma. So if you need to stand up for like 30 seconds, do it. I mean, let's do, yeah, stretch your arms, whatever. I think it helps because there is a lot of just knowledge transfer going on here. So, all right, so I appreciate the opportunity to come here, and I'm going to bring a kind of building along some of the things Cam just talked about, more practical applications, because a lot of the things that are going on that we've been talking about is really science and research and studies, which is all very, very useful, but now we're talking about the applications at the end of the day. The growers, the regulators, the water managers need to start making change, and how can they use this information to help influence that. So I wanted to talk about a couple of case examples really quickly. I could probably compete with Pam on how long I could talk, but I have less on my slides, but we could probably have a little, we could both filibuster for the rest of the day, but that wouldn't be fun. So I'm just going to go through some slides here really quick. And first, I see what you said. It's like they don't change here on your screen. They change up there. So apologies for needing to look up there and see what is actually going on. So the quick shameless plug, who is Zanjero? We're a comprehensive water resource planning firm based up in Sacramento. We work on a lot of strategic planning, water management, water rights, compliance, and really implementation and trying to answer the questions. Like a lot of water managers are challenged with getting everything answered. There's so many things on your plates right now that they have to manage. We're an extension of them to help answer some of those questions and bring more informed decisions. We work throughout the Western U.S. There's an email if anybody cares about that. Again, that was a shameless plug, so I'll skip that fast. Why do we use OpenET? So we used to use essentially paid for service, and we'd have to have contracts. They were expensive. They took time because you had to enter in a contract. Often it was the water agency, like our client might have been a public water agency, and they'd have to contract separately with a purveyor of some of the remote sense data, and we'd have to go through that, get a PO, get the data processed, get the answer back, and that just took time. And so it took a while. It was great information. It just took a while. So we transitioned when OpenET, we started using it 3 or 4 years ago. We were some of the early adopters. We got access to the APIs pretty early, which was really awesome, working with Maurice and the whole team. It just provides us easy and timely access. It lowers the cost to our clients. There's quick results. And it's, in my opinion, kind of an equivalent accuracy. And this comes into play. There's been some great research, some of the stuff we just saw today, some of the other sessions, the things DRI is doing to help show what the accuracy is. I want science to keep pushing all that, keep getting it more and more accurate. But in the meantime, we're going to keep using it and applying it to help answer questions today, because we can't really wait. So we'll keep advancing. As the science keeps advancing, we'll keep using the tools that way. So I want to just go through a couple of examples of how we're using this today. So first example is Merced Subbasin GSA. That stands for Groundwater Sustainability Agency. Back in 2015, there was a new law that got adopted in California because we're behind the times of a lot of the other states. We hadn't managed groundwater very well. It's kind of a free-for-all. So the state came in and said, there's a new requirement. You have to be sustainable by a certain point in time. You had to put a plan forward for this particular basin by 2020, get it accepted, and you have to be sustainable by 2040. So one of the requirements that came along with that was permitting groundwaters. The governor said, hey, you cannot, as the county that was in charge of putting in a new well and permitting that well, you can't do that unless it's in compliance with your plan. Well, what does that mean? So we wrote a policy to kind of say, hey, as long as you're still at the historic levels of groundwater, you got a collapsed well, you got something else going on, you need to punch a new hole in the ground. Right now there's a moratorium going on and people couldn't put in new wells, and that was affecting production, et cetera. So we wrote a little policy, and it allows you to have historic groundwater grandfathered in. Well, how do you get to historic groundwater when there's really no meter data from a lot of these users? These are groundwater dependent users. These aren't users that are sitting in an irrigation district. They don't have meter data. Well, there's this great tool, OpenET. Hey, we can get pretty close. So we would look at the data and generate and estimate applied water. So we'd look at that, and let's go to a kind of a sample. We'd pull off all and to subdivide the parcel. So this grower would say, hey, I'm looking for a new well to punch. We'd need to know where their existing wells might be that they're still going to operate. What are all the fields involved in a pretty much a commingled irrigation system, and try and get to some number that we could grandfather them in and what their use was historically. So we run through this. We get the ET. We can back off some precip. We apply some efficiency. Again, this is, we're kind of doing. I actually had one of my young employees was like, what does that mean? Thumbs up? I'm like, no, that's the old school approximate sign. So we'd get pretty close, So we'd get pretty close to this, and we'd talk to the grower. We'd produce something like this. So for each of those 15 fields, there was an ET rate. Obviously, the ones in January, December, and things were coming out from precip. So this is the map of ET. We'd convert that to applied water, and they'd look at a number. Oops. I guess I jumped too far. They essentially would accept that number and say, okay, we'll cap our total use and we'll start reporting, because that's the other part of the policy, is they were required to put on a meter and start providing data. So this is just an easy way to get to something that allows growers to put in new wells, get past a moratorium. OpenET allows that process to move through in a couple of weeks' time. So we can do that, have that interaction, be able to move quickly. So if a grower's lost a well and they're in trouble, we can get permission, get the permits and everything, and help that process. Example 2, we're in the same subbasin here. This one, as part of that groundwater sustainability plan, they have to reduce consumptive use by over 100,000 acre feet per year. That's a pretty big volume. That's consumptive use of groundwater by over 100,000 acre feet. So that's a big step. How are you going to get growers to make essentially what's going to be a 50% reduction in their current use? You're going to have to start talking to them. So OpenET allows us to begin that dialogue, to have a lot of grower workshops where we can pull up data. We can look at somebody's farm. We can look at their historic data. They can understand with that what the change might be that's coming forward. So we have these ramp downs that are, your use is here today, your use is going to have to go down to here in the next 10 years. So we're trying to help them with transitioning and business planning. And by looking at what's happening recently, they can start to get a better mental picture of what's involved and the challenges and how they may have to adapt their business to be able to become sustainable. So we would work on this grower outreach, and so we could locate their parcels and help them start to understand their trending total ET. We could help them understand monthly patterns, and we can help them see variations in fields. And again, that helps them say, well, shoot, maybe I got a really bad field here. Maybe that's the one I'm going to target to take out or to switch to another crop or something. And these other fields are the ones that are really productive, or I know I got different age. A lot of this is permanent crops, by the way. The almond conversation from Kyle, there's a lot of almonds going on down here. Those all have permanence. They all have their return on investment calculated. They can't just change tomorrow without massive economic impact. So we can go to this and we can say, look, pull this right out. You don't have to be subscribed. You can easily just grab this data for a parcel and see your cumulative use. You're like, okay, hey, I'm using somewhere, the ET is somewhere between 40 and 47 inches. It's depending, and there's probably a variety of reasons for that particular grower. And here's what it looks like across time, across months. They start to get a picture of this because they're used to, turning on the pump, I'm putting on 6 inches of water every 3 weeks. So this is kind of starting to make some sense. They can do the math and the translation between pumping and ET in their head. And they can look at raster views like this and see, oh yeah, so I do kind of have some hot spots or some spots that are having trouble in my fields. And yeah, okay, that would make sense because I see those trees are a little less healthy. So maybe that's where I'm going to start making some changes in those parts of the my field. Because again, massive change. You got to go for 100,000 acre feet is a 50% reduction in ET. So it's not like everybody's got to just take off the 5 inches in the morning session. They're talking about dropping 3 or 4 inches. We're talking about dropping 20 inches. That's massive change. You don't grow what you're growing today in order to be sustainable. So example 3, Nature Conservancy, one of our clients. We work public agency. We work with a lot of NGOs, work for a variety of privates. They had acquired some properties up in the Upper Sac Valley, and they wanted to fallow those lands, and they wanted to potentially transfer that. Now, in the world of California, you can transfer as long as you're not causing illegal injury to another party. They wanted to move it down the river, re-divert it out for refuge habitat benefits. Sounds like a great thing. Well, the regulators said, no, we don't like that because you're not one of the typical crops that we allow to be transferred. So we said, all right, well, let's look at OpenET data. We looked at it 2016 to 2022. We pulled all the data through some API push. And then we used CIMMYS, and I think, Kyle, you mentioned CIMMYS, right? So CIMMYS, California Irrigation Management Information System, has a bunch of weather stations scattered around California. Some have been around for a long time. There was one near this property that went back into the 80s. So we could do a correlation from the existing years, translate that all the way back, get a good picture of what this historic use used to be. And that helped us then say, as they followed this pasture, this happened to be pasture, some of it was hayed, some of it was just grazed. That's a non-traditional crop for purposes of water transfers in California. So the regulators, again, didn't know how to deal with this. So we established a floor value that allows us to have that conversation. This is what it started to look like. You can see this history, and it's really this recent period right down here where you can see the drop-off in ET. And we can say, all right, this is how much was consumptively used. Now, they actually have the ability to transfer the whole diverted right because it's under an adjudication. But that was another story with the regulators that we won't get into today because it doesn't have anything to do with OpenET. Example 4. This also gets into the regulatory world. We are federal water masters for the Santa Margarita watershed, and so we have to do an annual report. So as part of that, preparing that annual report, all the users are supposed to submit their use information. Well, we know how well that always goes. So generally, private pumpers do not have any data to share to us. Compliance reporting is around 75%, so we have to estimate for a lot of situations. So how do you start to estimate water use? Well, OpenET helps us look at that. And we can say, all right, here's a rough estimate. Now, obviously, if things start going negative and really on a basin-wide scale, kind of similar to Cam's discussion on the statewide look, on a basin-wide look, things are going in the wrong direction, we can get more refined and really go after who's maybe is misusing their water in the adjudication. But as long as the basin is staying pretty balanced and we're all kind of within the right, again, rule of thumb, rough approximation, we're probably pretty good. So using OpenET as a proxy is a really clean way of doing this. So let me show you what kind of happened when we have some situations. So a prior report, like maybe the year prior or 2 years prior, we may have had a field like this or a series of fields, and you can see they were all cropped. And we had some sort of data. And if that was available again in this current year for this current report, we could just look back, what did we estimate for last year, what did they report, and use that as a proxy. Well, unfortunately, the report that was available had a lot of cloud cover, and you really couldn't see what was going on from the satellite imagery aspect. And you're like, well, that's not really useful for reporting right now because we can't estimate what's going on. So if it's, again, similar, we used a prior report as a proxy. If not, we needed an alternative. OpenET gave us that alternative. So we plotted each of the fields to be able to look at what's going on, and we can get a sense of this. And here's the current image. This was after the report. There was a newer image that was available, and you could see they didn't irrigate and didn't grow on a bunch of those parcels. So this helped us get a better approximation for purposes of, again, a federal water master report. So again, I'm trying to give some examples of the practical, quick opportunities to use OpenET that are benefiting from all the research and the fact that we're finding, the accuracy levels are getting better and better and better, and they will continue to get better so we can rely on this data more and more. So it obviously allowed us to see that there was a reduced production and deal with that in the report. So an example of a couple of additional things that we're doing. And I hate looking at the board. I like to look out here, but I have nothing on my screen right now that really helps me know where I'm at. And I didn't commit it to memory, sorry. So we find ourselves turning to OpenET often for some quick answers on a variety of things. And they can be like, we're sitting there maybe working on some project, and we're like, wonder what that is. We can pull it up in 5 minutes. We're looking at the numbers, and we're like, oh, okay, that kind of makes sense. And so it allows some quick gut checks of what's going on. We've used it for urban water use areas, so we can look at large landscapes. We've even used it to kind of gut check the estimate of pool evaporation down in the Palm Springs desert area. And we're like, yeah, it is about 8 feet. That's what OpenET is actually showing on some pools. And I know the 30 meter is bigger than a pool, so you're having all sorts of little challenges there. But again, this is close enough that allows us to say, all right, that's probably relevant in a rough number for when you now have actual meter data. You can see how much of it is tied to indoor use, the potentially tied to outdoor use like pool evaporation, and pretty much every house down in Palm Springs has a pool. So we can also look at ET changes from when a field may be idled or replaced, and this is super important as more and more of the shift to the permanent crops in these water stressed areas have happened, and we need to now start shifting away. So you have a lot of tree crops were planted even 1 to 3 years ago in some of these areas that have to be sustainable. Well, we saw a presentation, I think Kyle was yours again, that was showing the bad approximation of young trees and better when you get more mature. Well, that better was also a higher volume of water. So we have to expect some of these places are going to keep going up in their total water use. And that's hard to manage if we have to actually have total water use going down. So having that information to look at some of those changes and be like, oh yeah, okay, I saw this field came out. You can look back through Google Maps and the little time series. I love that thing, by the way. You can look back and be like, oh, hey, look what was happening out on this parcel out in this time. So it helps us find those things and then have the conversation about policy with boards, with the stakeholders that are impacted, with public. And so it's very, very useful in just helping get a different visualization of what's going on and what needs to change. So we can work real time, like I noted before. We can pull up something with a grower. We can be in a workshop. We can just jump over to a computer, say, where's your parcel? We find it. We click on it. We start looking at some stuff. And that just allows the dialogue to continue rather than having this, oh, it's something from space and I don't trust it. It's getting more acceptance of this data source and this data tool, because we can't, well, not in California, you're not going to be able to meter every single well at an accuracy level that's going to get you there at a cost point that OpenET can give you instead. And that's going to be important because we have to look at overall long-term water use and see that trend going downward in a lot of places. So, like I said, that was a quick run through because I wanted time for questions for the panel. So that ends my time. Back to you.
Thanks so much, Greg. Great presentation, and a really nice way of tying together the competing interests from the engineering and the regulation side, and looking for answers using OpenET to present actionable information and answering these questions. OpenET as a platform is it's really exciting to see its developments to date. When I think about kind of what's to come and the changes and the improvements we want to make to it, and maybe some of the difficult hurdles or kind of a mountain we have yet to climb in terms of making OpenET even better, I think about just how far we've come. And so it's really a good motivating factor there. And I think all of these talks really just speak to the overall theme that OpenET and the Explorer tools and everything, it's really this platform for collaboration where the cooperative efforts that it facilitates are just as significant, if not more so, than the base knowledge and science that goes into the functioning of it. So thank you again to all the presenters today.